Hi, John Valvano here, and this video is just an introduction to the internet. Okay, um, in 445L, we're going to use the internet to take our embedded device and connect it up to the cloud. Here's some terms we're going to see in this class. The internet protocol is basically the way we're going to communicate with the internet. We're going to use the domain name service to look up, to convert a string www.weathermap.org into an IP address. Okay? And we're going to see two type of communications. Our lab is going to use TCP, Transmission Control Protocol, but we'll also talk about UDP. All right. So what is the internet, and what is the Internet of Things? Okay, so basically in the context of 445L, a thing is an embedded system. Okay, so these little yellow nodes here could be embedded systems. And so if we take an embedded system and one way or another get that embedded system to communicate with the internet, then we'll classify it as a Internet of Things. Okay, and so the actual topology of what Lab 4 will look like and Lab 10 is our alarm clock is going to be one of these nodes here. We're going to use Wi-Fi to communicate to an access point. That access point is then connect up to the internet. The other thing that can happen is our cell phone is also going to have an access point, and it's going to have Wi-Fi connecting to either the same or different access point. And we're basically going to communicate using the Blink server between our alarm clock and our cell phone. Okay. Now, the communication protocol is layered, and so the TCP IP layering is usually broken up into these four components. The media access layer is the Wi-Fi or the Ethernet. That's the physical layer through which our device will communicate. And then on top of that physical layer are a number of software or logical layers. The Internet Protocol is the next layer. And then, like I said, we're going to use TCP to communicate in lab. We could have used UDP. And then on top of that is our Blink application, which uses TCP packets to perform its operation. Okay, again, there's an application layer running on your alarm clock and a second different application layer, software layer on your cell phone. All right. As you might imagine, in a layered protocol, the lowest, we start out at the highest level where we just want to send switch information from the cell phone to the alarm clock, or time information from the alarm clock to the cell phone. In Blink, this will be done with pins, so there'll be an application layer here associated with the pins that we communicate with. And then as it goes down further, a TCP packet is then appended, which contains the address and the socket and all the things we're going to see about subsequently. And then the final layer is the big layer, the data link layer, which is going to embed all the previous information plus the IP header, which includes the IP address. All right, so one of the first decisions we'll make is whether to use transmit control protocol or a user datagram. And basically, we're going to have a bunch of trade-offs. Does it need to be fast? In which case, we'll use UDP. Does it need to be reliable? In which case, we'll use TCP. Okay, that's the basic high-level picture. But there's a lot of other fundamental differences between the two. In particular, in a TCP protocol, the endpoints, the alarm clock with the TM4C and the cell phone with the Blink act are called connected. They are attached to each other through their sockets. Whereas UDP, there's no connection. You know, it's basically you send information to an IP address and off it goes. And so therefore, because there's no connection, UDP supports multicast. In other words, where you can send to multiple destinations, or you can receive from multiple sources. Okay. UDP, because it's more secure, is handshaked. And so handshaking means if a packet is lost, it's going to be retransmitted. Whereas with UDP, we're just going to send up a datagram, send it off, and hope it gets there, and not worry if it doesn't get there. Okay. TCP is ordered. In other words, the packets are sent in a certain order, and therefore they will be received in that exact order. Whereas UDP is not guaranteed that if you send 20 packets, that they'll be received in the same order we sent it. And like I said, TCP is reliable. It will retransmit either on a lost packet or a broken packet, but UDP is faster. Okay. This essence of flow control has to do with what if your receiver is swamped, okay? If your receiver has a lot of work to do, where you're sending it, what TCP and flow control will do will recognize that the receiver, the server you're trying to send to, is overwhelmed and therefore slow down the rate in which it allows you to send packets to it. That's called flow control. Okay? Another very interesting difference between them that's not often recognized, and that is TCP is really a stream. Okay, when you send information with TCP, think of it as one great big byte stream. And yes, you send TCP packets, but there's no boundaries. The data is thought of as a byte stream. And therefore, when we use TCP, we will enforce or add on top of TCP those boundaries. And you'll see that in your lab when we send through a pin on Blink. It uses TCP, but the boundary is imposed at the application layer and not in the TCP layer. Whereas when we look at UDP, you will see that the UDP packets do have boundaries, and therefore built into UDP is this notion of you got a packet that has the beginning and the end, and the next packet has a beginning and end, and UDP packets have boundaries. All right. An IP address sounds like what it is, and that is it's either a small number like 32 bits or a much bigger number to contain the actual place in which I'm going to send it. Now you'll see that there are some addresses which aren't public. These addresses that begin with 192 turn out to be local IP addresses. And so when we interface with the internet, it's really two different networks connected together. So within the local network, we use these local IP addresses, and in the internet, we use the public. And as I've said before, the domain name service converts a string like www.weathermap.org into a physical IP address, and that's IP4, which is 4 bytes or 32 bits. The second thing we're going to do when we send to an IP address is assign a port. So a port is within that IP address. What do you want to do with it? Okay. And you will see that the Blink server and the openweathermap.org server is an HTTP, Hypertext Transfer Protocol. And when we connect into the server, we're going to go through port 80. So this is sort of a logical place within the IP address to take certain types of packets. So we're going to see port 80 when we send information. Okay, in summary, what's the internet? The internet is a system of systems, a communication system built on another computer system and built on another computer system. We, in this class, are going to deal with the lowest level, the edge interface, the connection between a physical node, which is our embedded system, and an access point through which we will send TCP packets to a server, and that server will then send TCP packets to our phone. All right, in the next video, we're going to talk about client server.